forward to go through these. So hopefully I'm going to spend less time than usual talking about these, and I really look forward to being able to then answer questions and do a good, have enough time to go for a good Q&A. That said, we're going to have to go really fast, and I know that some of the stuff in there has already been on the Moodle. I was looking through the Moodle last week, and I saw a number of diagrams, a number of graphics that I had done that you're going to see in this slide deck that actually already are elsewhere. You'll also notice, and I hope that you've all followed the course by Wolfgang Kleinwächter, which is has a recording on the Moodle. I'll be touching on many of the stuff that he's been talking about. Yeah, well, let's get going and let's move forward. And I guess, so I have the ability to move forward this way. Let's see, testing this. Wow, perfect, it works. Okay, well, 5 waves of internet governance. Yes, there are 5 waves of internet governance. There have been ever since the internet started. Essentially, the first wave was military. You're looking at 1957 to 1970 because a lot of work went on between the, during the late 50s and middle 60s. A lot of fundamental work to put together this network. It was all driven by military exercises and things. After that, it became academic. And then the next wave from the 90s onwards, caused by the invention of the World Wide Web, which we will be touching on, not the internet itself, just the web, just the, the voice, video, data, the more usable products, was all in the 90s. And you saw these big companies start up really small and grow really fast over that time period. Then we had mass media after the year 2000s, because, of course, things were going faster on the net. Things as in data rates were going faster. Mobile phones started having big screens. This started becoming really, another way to interact with the internet, and a lot of video video products were developed around that time. And then you had everything, everybody and everything from 2010 onwards, and we're 10 years later, and it's really gone in all sorts of directions now with the apps. On one side, a huge app market, applications on the mobiles, which use the internet as a back end with 4G, 5G, with the Internet of Things, all of that stuff that's coming over pretty soon. So first thing first, I guess we'll start with the history, and as many things, first, what is the internet? Well, it was a technology that was developed in the 60s. It's got a standards body that's called the Internet Engineering Task Force that works around multi-stakeholder development, so anybody can take part in this development of standards. It's a distributed system. It's a network of networks. So you don't have a single owner for that network. It's one network and another one, and they're all interconnected together, and they all carry each other's traffic, and there's no single point of control for these networks. But it does have a domain name system, which is a single domain name system to address all of the devices and people around the world. And it's fully distributed. This domain name system is fully distributed around the world. So, as you know, I think many of you might have seen this graphic. Lots and lots of different organizations that take part in internet governance and the internet itself, and in the development of this network. That diagram is one of the diagrams that I've seen in the Moodle. So I hope that you've looked at it more closely, but in there you'll find that you have both the Internet Engineering Task Force, but also the other organizations that I'm going to be talking about. So, as it started, well, it started very small. We're talking here in 1969, first packet switching node of ARPANET. So why did we start with the internet? Well, in the 50s, the Russians won the space race by sending the first satellite in space, a thing called Sputnik. It was like a ball with three little antennas, and it went straight into space. And JFK, John Fitzgerald Kennedy, went absolutely crazy and went, right, we can't lose this thing. We're not the first ones in space to send this thing over. What we're going to do is 2 things. We're going to go, and by the end of the decade, there was a well-known speech on this. By the end of the decade, we're going to send someone on the moon. Yeah, right. Okay, and then we're also going to have this kind of some kind of a communication system that can withstand anything, and any nuclear war or whatever. We'll be the last people standing. So these were the two projects, and of course, the man on the moon thing was more, I guess, caught more of the public's imagination, and this network of networks was not something particularly interesting for most people. So they publicized the man on the moon, and that came up in July 1969, and it happened. And then a few months later, the first connection between two ARPANET computers happened, and that was in September 1969, and you just had like one node and two things and a message that was sent between one and the other. And soon enough, before the end of the year, we ended up with a number of nodes, 3 nodes being connected together, and then a few more. And so it basically started out with this whole demonstration that packet switching can work, and you can send information from one to the other. And of course, there was a flurry of activity around that. And a number of people were working in different working groups across the United States. Now that you had that demonstration that it could work, many different universities and other organizations worked together. And the first thing was, how are we going to document this? And so Steve Crocker wrote this thing called RFC, Request for Comments. And the request for comments is when you have something that you want to present to the others, you write a paper, you call it request for comments, you put a number next to it. If the previous one was number 4, you got number 5. And that is a document then that you can put online or share with other people, and others can comment on it and say, hey, that's a good idea. Or, oh, God, that's a terrible, terrible idea. Don't even think about it. This sort of thing. But these essentially ended up as being the standards of the Internet. The Internet continued growing pretty fast. You can see in 1971, a lot more places got connected. And in 1973, the network grew to a size where the original protocols that were used, which were network control protocols, those original protocols were not really fit to the task anymore. They wouldn't scale well. And you needed to develop something that was going to be a lot more robust, reliable, and that was going to allow for the Internet to continue growing to more and more and more computers. And so Bob Kahn from Bolt Beranek Newman and Vince Cerf from Stanford University, those two guys worked together and came up with a protocol called TCP/IP, Transmission Control Protocol - Internet Protocol. And that's really the basis, the technology that the whole Internet has worked on regarding exchange of information, the whole technology that the Internet has worked on since that time. So in 74, they invented this, and then within the next couple of years, it was rolled out across the Internet, and so the Internet is now working on TCP/IP. And that makes those two people effectively the fathers of the modern Internet. By 1985, you can see that there were a lot of networks that were connected. Now, you didn't even look anymore at individual computers. You would just look at networks. You had the ARPANET on one side, because it was, of course, the Defense Advanced Research Projects Agency, DARPA, that was funding most of this work. You had the military network on the other side, MILNET, and then you had tons of other little networks that were connected over. You can see them over on this. In 1985, they developed the domain name system that was introduced. Why? Well, because until then, if I look back at this slide, until then, each one of the computers on these networks, each one of these were referenced with an IP address, so this is like a number, and a name. And they were referenced in one host file that somebody had to update. Now, you can imagine, when you have 10, 15, 20 different places, it's still okay. You can still catch up every day and write the list of new computers and devices that got connected. When you start having thousands of them and thousands of updates per day, it becomes extremely hard. And that's why they decided, right, we can't have everything under .ARPA. We need to have a division. So we'd have MIL for military, Gov for government, Edu for educational, Com for commercial, Nets for networks, and we'll use also org for anything else that goes around there, any organization that doesn't fit in the other categories. These were the starting top-level domains, and there would be a file that would have the name servers that would work for these top-level domains, and that was the only thing that needed to be updated. And then each one of the organizations that were in charge of each one of these top-level domains would maintain their own file to update their own file. And therefore, you end up with some kind of a tree. And we'll see that in a moment. But it was much easier to update because everyone was updating their own little part of the network. In '89, a number of things happened. First, the military network separated itself. Now, this could have well been because of the 1984 film called War Games, if you remember. Well, maybe some of you might not remember, but check it out. Check it out. It's this film where this kid plays tic-tac-toe, a game with a military computer, and effectively hacks into it, and plays global thermonuclear war. And of course, everyone who in that generation watched this a few years later when they were at university, such as me, for example, would think, hey, let's try and hack the US military. Why not? Of course, the US military were not amused, and therefore they completely cut themselves off and put specific gateways between their military network and all of the other networks that were there. So you immediately started looking at aspects of cybersecurity. MCI started a commercial email service, and it was brand new because by then you just had simple services, but MCI was one of the first ones to have this for commercial companies, because more and more companies were getting involved with the internet, because you'd have, as I mentioned earlier, Bull Beranek Newman, that's a company. So they were defense contractors to start with, but slowly they started working and thinking, hang on, if we could use the internet to talk between each other, not just on military contracts, but we could actually also work on for our everyday work. Even the accountants in the company, even the accountants are asking for it. Yeah, they can email invoices. Oh, God, very, very different than the previous thoughts, which was just exchange scientific data. So things started becoming a bit more commercial, but the rest of the internet was still paid for by the U.S. taxpayer, because a lot of large parts of it were run by universities that were funded by the US government, and networks that were funded there. And so it went from 80,000 nodes to 160,000 nodes in November. Very quick. 1990, 1991, we started seeing more commercial services. PSI, UUNet, ENS Corp, the National Science Foundation Network, which was the one that was supporting all of the universities, was in full development. It was connecting every single university it could think of in the US, but it started enforcing acceptable use policies. So commercial traffic would suddenly get blocked. And that, of course, got other companies to think, well, you know what, we have to bypass this. Instead of using the National Science Foundation Network, we need to go straight and talk to each other. And they started working out peering agreements. So our network carries your network's traffic, and your network's traffic will carry our network's traffic. And this is still how the internet works today. There's still peering agreements between the different carriers out there. That's how, when you email someone or you connect to a service that's on the other end of the planet, it goes via so many different providers, and they all have peering agreements to carry the traffic ahead. In 1991 also, the commercial internet exchange started. It was the world's first neutral access point, so a bit like an internet exchange point, IXP. And they basically said, instead of having everyone connected to a commercial supplier somewhere, maybe we can all interact with each other and see, basically put the network together in line with the traffic, so that we don't have these problems in some places where the network is so busy. We can just have an exchange point locally. And this is particularly important for those countries that started getting connected to the internet, so that two different internet service providers wouldn't send their traffic overseas and then back locally. In 1990 and 91, you just had simple services, as I mentioned earlier. So you had email, file transfer protocol, and then this thing called Gopher, and I'll show you that in a second. And there's a wide area internet information service, Archie, a whole lot of services that have disappeared today. Telnet was still around. It still is used. Well, these days it's been replaced by a more secure protocol, but all of these services were all text-based. This is an example of Gopher. So that's an example from back in the day when I was there, when I was using this. And you can use arrow keys to go up and down, or you can select the number that you want, or you can use arrow keys to go into the tel thing that you see there here. And that's, of course, that's already working as hypertext. Hypertext being, you go on a word, you click on it, or you select it, you press return, and that sends you to another document. So hypertext worked already, but it wasn't using voice and video and things like that. It was just text-based. And so in 1992, Tim Berners-Lee invented HTML. And effectively, the hypertext markup language was the start of the World Wide Web. And I remember I was a student back then in Imperial College, and this guy from the computer center, he was a student too, but he was one of these really like whiz kids that used to work at the help desk. So if you had a problem in computers or networking or things, you would just dial him up, and he used to do that part-time to make a little bit of money on the side. And he ran over to me, he's like, Olivier, you gotta try this, you gotta try this. And I'm like, try what? You gotta try HTML, it's amazing. It's have you heard of Tim Berners-Lee? No. And this is exactly what happened. I was like, okay, what I had some information that was on Gopher, and he goes, you got to transfer all this to the web. The web is the future. And I thought, oh God, just another thing that's going to be the future. Everything is always the future. And indeed it was. And I transferred these things over. I learned HTML, and this is where PC started becoming so powerful, because you had voice, data, video. And so I downloaded this software called NCSA Mosaic from the University of Illinois at Urbana-Champaign, and I downloaded my first web page. And this is maybe not the first one that I downloaded, but this is one of the web pages that I downloaded at the time. And this is what NCSA Mosaic used to look like. It was in color. Not very good quality color, but it was in color. And it had these little things which were really interesting. That see these little buttons that were there, and you could actually press on the button. You could hear this guy, Lou Gerstner, the chairman of IBM, actually talking to you, or CEO of IBM, going like, oh, this guy's actually talking. You can hear his voice. There wasn't video then, because the quality and the speed of video transmission wasn't very good. There were some video tests, but it was not working too well. But that's one of the first pages, and you can see the power that you have there. Immediately, many companies started picking up on this and on services they could offer that were not towards technologists anymore. You could actually have these services working for everyone. And so you can see here the first commercial web browser, Netscape. Netscape in 1994 was created. It was actually people that had created NCSA Mosaic as students in the university that then moved on and created their own startup, and they made Netscape. In 1994, Web Crawler, the first crawler that would basically, it's a machine that would go from one machine to another and try and find all the links and effectively put together some kind of a catalog of what the internet has. It's like a search engine. Yahoo started in the 1995. They looked at a slightly different way. They actually used students and humans to go and surf pages, or you could submit your web pages and they would review them and they would catalog them and put them in a certain order so you could find it, and it was part of this big Yahoo catalog. A few years later, they found out as well they couldn't keep up, so they actually embraced the whole thing of using an automatic spider that would crawl the web to fill in their Yahoo pages. Alta Vista, run by Digital Equipment Corporation. These guys were making huge computers. They thought, hey, we could use our computers for something useful, finally. And so they basically used this and created that service. Ask Jeeves was one search engine in the UK. And then Google only started in 1998. So, you don't need to be the first ones to be the ones that remain behind, because if you look at most of the ones that were there, you'll notice quite a few do not exist anymore. Microsoft was not the first company that jumped onto the net. You can see that it was only until 1995 they did not even have a web program to surf the internet. So Internet Explorer version 1 was pretty terrible. And it's only in 2005 when things started picking up, speed started picking up, that you had video sharing with YouTube. You can see here the speed at which the internet grew. And I took Asia as an example. So in yellow and red crosses here, you see full internet connectivity in November 1993. And in green, you just had some kind of a dial-up, sometimes just email dial-up. And just a few years later, the whole region was pretty much covered by full internet. So it just grew at an unprecedented rate. You can see here a network map. That's not really a network map. It kind of shows you the interconnection between continents. Very, very quickly, companies, telecommunication companies, decided that it was time to wire the world. Now, a fast way to do it, or faster way to do it, was to send a satellite into space. So we started out with a lot of satellite connections. Australia was connected by Telstra, which was a satellite connection. Because there were no links, no fast links to Australia, not enough bandwidth, and so on. But over the years, more and more cables got laid under the sea for the reason that you have less delay in a fiber cable that goes under the sea than in a signal that has to go all the way out into space and all the way back. And delay is a really important problem that you have if you're going to transmit voice and data and video all in the same way. Video and voice do not like delay. And I hope it works, but if it didn't work too well, you'd also have a disconnect between my voice and my video. And so you'd see my lips move when I'm not saying anything, and you'd see my, it's terrible. It's not nice. Anyway, so lots and lots of connections around the world, and it just kept on growing at such a crazy rate. And for the simple reason that you had this end user principle, any type of traffic was allowed. There was no filtering. Now there is, but back in the early days, there was no filtering. And so it was a champion for innovation. You had tons and tons of people around the world that would think of new ideas and thought, maybe we can implement this and offer this on the internet, and they would be able to offer it on the internet. And if it was successful, it would be successful very, very fast indeed. The smallest company would just become absolutely huge. And look at Google. They didn't start. They had started at some point, and it grew very, very fast indeed. Now, of course, the moment that you start speaking about the internet existing and everybody using it, some people started thinking about, how can we govern this? And first, this whole definition of internet governance. And so there was a group of people at the Working Group on Internet Governance, the VSIG, that presented a final report in 2005 at the Tunis conference. And it was a conference that was hosted by United Nations. And they defined internet governance as being the development and application by governments, the private sector, and civil society in their respective roles of shared principles, norms, rules, decision-making procedures, and programs that shape the evolution and use of the internet. It probably shook the world when they wrote this, because a number of governments in particular were not too happy about a definition where you would have the different private sector and civil society working together with them. But this is a definition which has been accepted and has been in place until so far. Internet governance is not just one topic, it's actually a collection of topics. Our friends at Diplo did this great graphic here of something that's always in development, always being built, and it's got so many different component parts to it. It's got cybersecurity, human rights, it's got sociocultural issues, it's got millions, not millions, but thousands of different facets to each one of these development. And it's also undertaken by lots of different organizations. As I mentioned earlier, there's not a single organization that runs the whole internet, but many different organizations that work together to make it happen. So I guess the next thing, we can look at a few of these organizations, that sort of significant ones. The Internet Society being one of them. I think many of you might know it. It was founded in 1992. It was there to provide some kind of a leadership for the to tell the world about the internet and make sure that the internet is for everyone. It was dedicated to ensure the open development of the internet. It's the legal home for the Internet Engineering Task Force. So those internet standards could be built as the time went. It grew with a number of chapters to cover throughout the world. You can see here there are over 100 chapters, and I hope that many of you are members of your local chapters. The Internet Society has got these two organizations that it helps out, that it funds. The Internet Architecture Board, which is part of the Internet Engineering Task Force, is a committee that looks at the architectural oversight of the IETF activities, looks at the Internet standards process, and it appoints also the RFC editor, the person that is in charge of publishing the request for comments. The IETF has got all these working groups that look at every aspect of the technical side of the internet, and they are the ones that brought you pretty much all of the underlying internet services, from security parts of things, but also the protocols, email, all of the services that are there, but not the web. The web is done by someone else. ICANN is another organization that's of importance, founded in 1998. When the US government did not wish to continue dealing with coordination of the DNS and decided to pass it on, again because it was costing money for US taxpayers. So they said, let's create an organization to pick this up. And so it was a not-for-profit, public benefit corporation with multi-stakeholder standard development. So it's got all these groups, supporting organizations and advisory committees that work together to create policy for domain names for the top-level domain. It's multi-stakeholder, it's bottom-up, and it's consensus-based. The domain name, I mentioned top-level domain. The top-level domain is this thing. .org is a top-level domain. It's the top part. And then underneath that, you've got a second level. Here, ICANN, a third level, meetings, and a fourth level, www. So ICANN is just in charge of the top level part, the .org part. Then you've got these root servers. So the root servers effectively are the ones that will take those top level domains, that will take that database of top level domains, and that will then work at the top of the pyramid to provide you with the name servers that run each one of these top-level domains. And so you've got 13 root servers to start with, and they are basically the start of the DNS. When you type an email address or you type a web address on your browser, and you want to go to VSIG .moodle I can't remember what the extension was, .education or something. You type this, it will actually look at the top level domain, and it will try and match this. And so these root servers will do this job. They have to be very, very, very stable. The A root, which is the one that's over here, is run by VeriSign. It's a contract that VeriSign has with ICANN in order to run the A route, and all the other ones are copied from the A route. Now, of course, looking at this map, you think, ooh, everything is based in the US. So actually not so, because you now have many, many instances, copies of this root server system. You can see they're scattered all around the world. This map is found on rootservers.org. You can zoom into it, and you can see then all the way down to the individual root servers. I really encourage you to look at these. And since the last time I did this speech, this talk, a couple of weeks ago, I think it used to be like 1,321 instances, and now we're 1,341. So 2 weeks ago, there were 20 less than there are now. The regional internet registries are also very important organizations, and I've seen that in your Moodle file space there are already examples of what these are. Each one of these distributes IP addresses, those famous IP, Internet Protocol addresses. I've given an example here, 192.0.0.1. This is a local address. These are the addresses. You'll notice them sometimes coming up on your screen. every computer that's on the internet needs one of these, and so there's a whole network of these organizations that are there to distribute these addresses, both the previous version, IPv4, I've just quoted one, and the IPv6, which is the next version, much, much longer addresses. All these are effectively distributed. World Wide Web Consortium, I mentioned it earlier. So Tim Berners-Lee and Jeffrey Jaff are the people leading this organization. And the World Wide Web Consortium's W3C is to lead the web to its full potential. So they are updating the HTML hypertext markup language. Now I think we're on number 5, and they continue to have more complex protocols that are developed at the presentation layer, so you can have even better web pages, which are even more exciting, and also online games and all sorts of other things that go on there. And certainly they work also when it comes down to the cybersecurity of these of this level, this layer. The ITU, International Telecommunications Union, is an organization that started a long time ago in 1865, and it was dealing with charging for telegraph and telephone services back in those days. It actually did a lot of work towards today's telecommunication networks. It was very strong in developing standards for modems in the 80s. I guess most of you don't remember modems, but they were these annoying little boxes that you needed to use to get connected to the internet, even in the early days, that were making a lot of noise and which would fail half the time because the line wasn't good enough. But these were standards to try and get things working, and each one of these standards went really well. But in the late 80s, the ITU completely missed the opportunity for the internet. And so it was kind of sidelined in some way in this regard. If you look at the ITU structure today, you've got a very strong potential with regards to the radio conference, and all to do with radio waves and radio spectrum. That's where all of the spectrum for your mobile telephony and televisions and all that, and all these services are allocated. And then there's got the technical track and the development track, and these deal with ICT, information and communication technologies in general, but not so much into the internet. Now, that being said, some study groups do try and focus on the internet, and the World Conference on International Telecommunications, the WCIT, took place in 2012, and there were some parts of some proposals in there that the ITU should look into the internet. And it was not seen as a good thing by many people who were involved in internet development. And why? Well, because the ITU is primarily just governments talking to each other. ITU members are governments. You also have sector members, which are organizations that can be either commercial or non-commercial organizations. But the final say, the final decision is made by ITU members, by the member states. And so that was not something which many people wanted. So you ended up with this problem. The conference did not end up with a new round of telecommunication regulations. Many countries did not sign the document. And so a follow-up World Telecommunication Policy Forum was put together, held in May 2013, which was an opportunity to try and calm the game a little bit. But they didn't come up with so many policy recommendations. There were a few that pertain to internet governance. And then the next one is WTPF 21 in Geneva next year. And we'll see how that goes. Now, there's also the WTDC, World Telecommunication Development Conference, that took place in 2017, that looked more at at any new protocols and services, and objectives for the development of telecommunications. You know, you have all these new services that are coming up, like 5G and other new things that are gonna, I wouldn't say take over from the internet, but certainly bring the internet to just another level. And so these are the groups where some of the work is taking place. The Plenipotentiary Conference, the last one took place in 2018. It's a 4-yearly conference for all of ITU. It had elections, it had a strategic plan adoption, and again, it had some resolutions that were touching on on the internet itself, and it didn't make much progress either. But it did have a lot of ICT decision makers coming together. You know, there are a lot of these conferences that are taking place, and so the ITU conferences is one of them. The other ones are ones that the United Nations are pursuing. So there's the Internet Governance Forum, which I think many of you might have heard about. There is the Commission on Science and Technologies conferences, which were running over the years and hosted by the United Nations Conference on Trade and Development. A lot of it is to do with development of the internet in those parts of the world that do not have a good internet service, or that don't have an internet service at all. UNESCO also was involved with development work with regards to the internet, and now the UN General Assembly is even looking at this, thinking on whether there should be some standards or there should be some push by the United Nations to influence the direction that the internet is taking. And of course, the UN had organized the World Summit on Information Society. So it's not new that the United Nations are involved in this game. It is the UN that gave rise to this definition of internet governance that we saw at the Tunis conference in 2005. And you can see also there is a World Summit on Information Society, Information Systems, WSIS plus 10. And that was a review of what happened in 2005. So there were 2 review sessions. There was UNESCO, there was ITU, and there was also a review of the Internet Governance Forum to try and see if first the Internet Governance Forum had actually done what it was supposed to do, and 2, whether it needed to evolve. And I guess it's time to talk about the Internet Governance Forum. It just happened. The latest one just happened. It wasn't a face-to-face conference. As you know, this year we've had COVID, so it was the first IGF of its kind. That was a virtual IGF. It lasted for 3-4 weeks. And if you've missed it, then I would really suggest that you go on intgovforum.org, as you can see on the screen. Go there and check out the sessions and check out all the recordings of the sessions. It was very, very interesting and exciting. And parts of the session, some of the sessions looked at the possibility for IGF to move on and to grow into an IGF plus model, where there would be not only just discussions on internet governance, but also some decisions perhaps made, or as a starting point, maybe some final consensus documents to be published, and then to be followed through with intersessional work between the different IGFs, so that you don't just have one IGF last year and then one this year, nothing happening in between the 2. So lots of things going on in that space. You can see there are a lot of national and regional IGFs. They're scattered around the world. There hopefully should be one close to you. I wanted to also talk about multilateral and multi-stakeholder. I'm a real believer in multi-stakeholder processes because it's an environment where you have governments, businesses, civil society, individual users, and technical community that come together and work on projects, work on problems together, work on challenges together, and together they find a solution. Yes, it's difficult, it's not simple, but at least you get through with this. Multilateral is different in that governments talk to governments, and sometimes there are bilateral discussions between governments and industry, but never is everyone under the same roof speaking together. Each one of these systems has an advantage and inconvenience. Multi-stakeholder systems have an advantage of being able to engage everyone together. The difficulty is to get everyone to agree with each other. Often you don't get consensus, and it sometimes has the tendency to be a bit theoretical. So you need to work hard at it, and there's also a problem with some stakeholders not being funded to do these things. Multilateral, and I haven't got a slide for multilateral. Multilateral has got a problem, I think, that if bilateral or unilateral decisions are made, it doesn't mean that everyone else will follow. And also, it doesn't mean that the decisions have been made with the most information or most reliable information possible. It might well be that some decisions are made politically, and that sometimes is not the right way forward. There are lots of, and of course, it's when I'm speaking, there are lots and lots of global events that are taking place. This year was different, but this here was the travel schedule of a good friend of ours. Unfortunately, Marilyn Cade passed away a few weeks ago, but her travel schedule for 2019 was that. You can see all of the different conferences that were taking place. It's just really crazy amounts of traveling. And of course, that's because there are so many challenges still ahead of us. There's fragmentation of the internet for so many different reasons, some of them being political. There's regulation. Many governments, especially with COVID recently, have decided, you know, perhaps it's time for us to regulate the internet. Well, regulate, but regulate what? Do you regulate the services, regulate the information? It's all a bit messed up, you know. There's control. Not all governments are democratic, and some find that the internet is a bit of a problem for them. There is the whole discussion, a whole debate on encryption. To encrypt or not to encrypt? That is the question. Cybersecurity, huge problem. As you know, there have been so many different cybersecurity attacks recently. There's been a massive rise in those cybersecurity attacks. Hackers and people that want to get your credit card details and all sorts of other things. Really, really terrible. There's a whole debate about privacy and data governance. All of these companies that propose free services to you that collect your information, collect your data, and then resell it to someone else. And, you know, who owns this? It's been a real concern because your privacy has pretty much disappeared in so many cases. And then, of course, there are all these new technologies, 5G being on one side, this thing that's being purported to change our world, and then the Internet of Things, where devices will talk to other devices without humans being involved. And we know what that is all about. So what needs to be done? Well, the Internet train is here. Don't miss it. Just you know, jump right onto it. It's going to continue to grow in ways that we haven't even imagined. And because of IPv6, this newish 10-year-old, 20-year-old maybe protocol addressing a system, it's going to hopefully continue to be able to grow without any technological problems. And then, you know, get engaged with these multi-stakeholder processes, ICANN, IETF, the World Wide Web Consortium, the Internet Governance Forum, because it really is you that will be writing tomorrow's page. So the pages 67, 8, 9, 10, you know, whichever pages on that slide deck are the ones that you are going to be writing. And so I think that's pretty much all in my conference for the time being. I'm happy to answer questions, and I've rambled on too long, but hopefully we have 15 minutes.
Great. Thank you. Olivier, this has been great. I was getting a bit of echo. I think it's okay now. Okay, so I'm asking people to jump in and post your questions into the chat. Can you see the chat as well, Olivier?
Now unmuted.
I can indeed, yes. Let me have a look. Oh dear, okay. So who chooses the questions? You choose them, or?
I'm waiting for can't believe I'm on echo now.
You probably have an echo because I'm not using headphones here, so that, and probably my computer is now thinks that you don't exist.
Okay. Maybe I'll just call out. I noticed that Nestor is going to be speaking at his IGF Peru event, which is fantastic, and that's something anyone can get involved with as well. So do reach out. And there's the IGF Youth as well. I recently spoke at the IGF India as a speaker. So do definitely get involved. They're all praising you, Olivier. So look at that. it's always a pleasure to hear all the knowledge of the master, Olivier Crepin-Leblond. So Nestor is very kind this morning. Amazing summary for the internet history.
If I could say, this is just my version of it. There are many different versions of the internet's history. Marilyn Cade, just to mention her, gave an amazing example of a few anecdotes that she had in the early days of ICANN and the creation of ICANN. And I really suggest that you listen to that recording. I think it's available out there. Listen to the recording. It's quite fascinating. Often what you find out is that the internet is not even just a network of computers, because you think, oh, well, it's a network of networks, network of computers. Well, there were some networks that were larger than the internet before the internet was created. But the thing is, it is the internet that became what it was because of the fact that it was filled with end users. To me, there wouldn't be so many services on the internet if you didn't have as many customers, potential customers on the internet. So the big difference between the internet and any other network out there is you and me, is the users, the people that are using it are the people that actually then got those services to be offered to them on the net. And that's really quite magical. A lot of people say, oh, well, we're going to replace the internet, or some countries say we're going to build our own internet, or we're going to replace the internet with our own internet. And it's very difficult to do such a thing, because it's a chicken and egg scenario. What are you going to bring first, the users, or are you going to bring the services first? If you bring the services, you might have to wait many years before you'll have enough users to make the services worthwhile. And if you bring the users on there, if they don't find any services on that new network that you're designing, then you've got a real problem as well, because they're not going to use it. So it's really a complex equation to have reached the level that we are at now. And I think a lot of people underestimate the miracle that has happened to bring it to this level. And some of the difficult times when the internet was just that far away from completely collapsing. And certainly the times when the US government turned around and said, we don't want to run this top-level domain system anymore because we have Senator XYZ who is asking, how much is this costing US taxpayer? And the president has asked, and now that we gave a number, he is horrified and says, we need to stop this right now or we'll lose the elections. This is the sort of thing that they needed to come up with some suggestions. And a rival organization, the Internet Ad Hoc Committee, which was composed of the Internet Society and the ITU and a few other organizations, came up and said, hey, maybe we can run the root system. Maybe we can move this. And that would have meant a new route that would happen from Geneva that would have been mostly coordinated by governments. And of course, the history showed that things happen in a totally different way. And the route was actually started over in, continued being run by ICANN and by the usual root service system. So anyway, lots of changes like this, and sometimes it just happened by chance that things happened how they did.
Great, thank you. I've added, I think you mentioned Marilyn Cade, and I mentioned her earlier on, but I put the link to our the video that we did with her on the history of the internet, so it's worth listening to. But it's also including all the speakers that we had in Group A as well for you to see as well. Now, I have a question from Nestor. What is your vision currently seeing its development for the internet in the next 10 years?
This question always comes up. And it's funny because I've often been completely wrong in my suggestions for the next 10 years. When Amazon started offering services, so there used to be a service that used to sell CDs and it was CDs and what was it? And DVDs on the internet, and it was called cdnow.com. I don't know if anybody remembers this. CDNow was one of the first retailers to sell CDs online. And then Amazon started and they said, hey, you know what? We're going to sell you a book and it's going to be free of charge. Shipping will be free of charge. So you buy a book and you'll get free shipping. And I was doing the calculations and thinking, wait a minute, the book costs $10 and it's free shipping, and they probably get it for $8, but now they're sending it to me from the US, which cost them $5. They're losing money. They're losing money. This company has never go anywhere. And I basically forecast that Amazon was going to fail within 5 years. Now you can see this is the kind of forecast I come up with, and now Amazon is probably one of the largest, if not the largest, retailer around the world. So how is the internet going to develop? I think we're going to see lots more services. I'm really looking forward to what's going to happen with 5G, with this overlay of networks. So you'll have some networks that might need high reliability, very, very fast speed that will.
We lost you, Olivier. Olivier, I don't hear you. Okay. No, I'm keep trying.
This is great. Okay. Does it work?
Yes, it does. Okay, go ahead.
It works again. Yeah. So it's probably where the internet will probably work like this. Who knows? I was saying that with 5G, with all of these new technologies that are out there, what you're going to end up with are some services that are catering for high availability, high reliability. And that might run on an overlay network, specific network for itself, and then that will interface with other networks. And there's always interfaces, but it will interface with other networks that will be much more like the internet that we know today. One thing that is sure is that the costs are going to continue being less and less, and that means there's going to be more accessibility and access across the world. More people will be able to access the internet than anyone else. At any other time in time. I'm looking closely at these new satellite services that are currently being put together, 30,000 satellites on one side and another 15,000 on the other. I'm not a strong believer in those because many different other organizations have tried 10, 15 years ago and failed miserably because you need to have a lot of customers. And satellites are far. Satellites, you have a mobile device here. At the moment, it connects maximum 3 kilometers away. So it needs to use battery to connect 3 kilometers away. With 5G, it might connect to something that's just 10, 20, 30 meters away. So it will have longer battery life. If you have something that works with satellites, you have to zoom in all the way up. That's very, very far out. So I'm not that trustful of satellite services, but certainly when it comes down to the fast speeds that we're seeing today, I think they're going to go worldwide because technology is going to become even more cheap than it is today. I'm even in developing countries, it's going to be a real game changer. I already see this as being a game changer today. I was in India. The last time I was in India, I saw people sweeping in the street on their mobile phone. And I'm thinking, wow, these guys are on there, or they go and they buy tickets on the internet nowadays, train tickets on the internet from over there. Well, maybe 5 years ago, I wouldn't have imagined this in a country as huge as India. But it seems to be a trend that goes worldwide. The only difficulty, I guess, is the political situation, where some non-democratic governments are not seeing this with a good eye, and they would rather control things and restrict things, and they might introduce all sorts of regulations that might slow down the development of the net in that part of the world. But I guess this will be localized, and it's all about you. It's all about you being able to convince your local authorities that you need something that is global, that is open, and that is reliable.
Thank you, Olivier. I'll just do a final comment and we'll wrap up. You've had a chance to look at the course material, and I'm sure you've had a chance to look at the introduction by a number of the students. Is there any comments you would like to pass on?
I tell you one thing that I found really, really interesting with the introductions from all the students is that it's such a diverse community. And this is the exact mirror of what the internet is. The internet is so diverse; it's very difficult to qualify it as a the sort of what is the internet? It's just a group of so many different services, such diversity out there. And it's the same thing here with with the students and seeing the diversity and the different outlooks that each person has. I think one can learn a lot by each other as well, and that's one of the parts that is really that I would like to be able to emphasize, is that yes, the material that is on the website is a great starting material. It's a great basis for things, but I think you also have a lot, each one of you has enough to be able to share with others. And sometimes, and I've done many schools of internet governance, including ones which were the summer school of internet governance that was happening in Meissen every year, and spending the whole week with students. You tend to learn a lot from each other. So I would really encourage everyone to learn a lot from each other, and you'll make friends for life. You'll make colleagues for life. And maybe one day, hopefully, you can also meet the people that you might have just met online, but with whom you forged some good links.
Great. Okay. Well, thank you so much, Olivier. This has been an entertaining hour. It just disappeared on us. So again, as always, it'd be a pleasure to see you in person. Perhaps maybe at the next ICANN meeting in Cancun. If not, maybe another time. But who knows? You know, this is strange times for sure. Okay, well, folks, I'd like to thank Olivier and to thank all of you for joining us today. And we'll be back again for next week session. And as we've mentioned, we'll be touching deeper onto the multi-stakeholder model. Again, this concludes the meeting today. Thank you all for joining. And please join in the discussion threads, ask questions, share information, and we will all see each of us online next Monday. Thanks again.